Hello and welcome to Tribe Topper. In this video session, you are going to learn about electric current. You know that whenever there is a charge which is flowing in a conductor, we would say there is an electric current in the conductor. Like if I say I have a wire, suppose this is a copper wire or aluminum wire, any wire lying. If it is not connected anywhere, it does have electrons, but the free electrons are just moving around randomly zigzag motion such that there is no net movement in any one direction. So there is no current. So if you touch this wire which is lying without any connection, it's not at all harmful. But the moment you connect a conductor, now you can see here there is a conductor, and if I connect this conductor to a battery, then immediately this is negative, this is positive terminal. This aligns the electrons instantly. So all the electrons, they will be directed towards this positive terminal, and they will be repelled from the negative side, because we know like charges repel and unlike charges attract. So the negative terminal pushes or repels these electrons, and they are pulled towards the positive terminal. So this way a current begins to flow. We say an electric current is set up in the conductor. So basically it is the motion of electrons or any other charge, like in case of battery or electrolytes, there are the ions which are flowing. So we would say whenever there is a flow of charge in a conductor, the current is said to be flowing. Now, mathematically, we say electric current is the rate of flow of charge. So it's not just the charge flowing that matters, it's how much charge flows in a given time that is current. So current means the rate of flow of charge. That simply means charge over time, because the rate of something means you divide it by time, and since here it is the rate of flow of charge, so you will divide charge by time. The unit is ampere, so 1 ampere is equal to 1 coulomb charge flowing in 1 second. That means if 1 coulomb charge flows in a conductor in 1 second, then the current is said to be 1 ampere. Now let's find out that how many electrons are present in 1 coulomb of charge. So in the last video sessions, we have learnt about the quantization of charge, where I gave an equation that Q is equal to N times E. Therefore, how many electrons will be present, that is N, is equal to Q over E. Now the charge I'm talking of is 1 coulomb. So Q is 1 coulomb over E is the value of charge on 1 electron, which is 1.6 times 10 to the power negative 19 coulombs. So coulomb would cancel, and dividing 1 by 1.6 into 10 to the power negative 19, you get N to be 6.25 times 10 to the power 18 electrons. So that means when I say 1 ampere current flows in a conductor, that time 6.25 into 10 to the power 18 electrons flow in 1 second. That's a huge amount of electrons. So let's discuss a question based on these formulae. So in a shuttling ball experiment, the ball moves between the two charged plates at a frequency of 0.67 Hz. The ball carries a charge of 72 nanocoulombs each time it crosses from one plate to the other plate. So A part, calculate the average current in the circuit. Now we have the frequency being given of shuttling the ball. So the ball is moving between two charge plates at a frequency of 0.67 Hz. So frequency is 0.67 Hz. So that means what is the time period of one oscillation, that is ball shuttling from one plate to the other and back. That will be the total time period T, which is 1 over F. So you divide 1 by 0.67 and you get 1.5 seconds. Now this is the time to go from one plate to the other and back. But we are here given that the ball carries a charge of 72 nanocoulomb each time it crosses from one plate to the other plate. So the charge which is carried here, 72 times 10 to the power negative 9 coulomb, is the charge going from one plate to the other plate, not back. So that means the time that we are interested is half of the total time period. So that is 0.75 seconds. Therefore, the average current is simply Q by T. The Q is 72 times 10 to the power negative 9 coulomb upon time is 0.75 seconds. So I hope you understood why the time is 0.75 seconds, because time to go from one plate to the other and back is 1.5 seconds. So only going from one plate to the other, that is half of it, 0.75 seconds. And in that time, the charge transferred is 72 nanocoulombs. So the average current is 72 divided by 0.75. And we get 76 nanoamperes as the average current. And in the B part, they ask, what is the number of electrons transferred each time the ball touches one of the plates? Now, each time the ball touches one of the plates, the charge is 72 nanocoulombs. So we have Q each time transferred is 72 times 10 to the power 9 negative 9 coulombs, and E, the charge on one electron, is 1.6 times 10 to the power minus 19 coulombs. Therefore, the number of electrons transferred we'll calculate again from the same equation. Q is equal to Ne. Therefore, N is Q by E. So that is 72 times 10 to the power minus 9 upon 1.6 times 10 to the power minus 19. And we get 4.5 times 10 to the power 11 electrons are transferred each time the ball touches one of the plates. That's all in this video session. In the next video session, you are going to learn about drift velocity.